Mole-to-mole and mole-to-gram problems. Have a calculator out and let's solve some of these stoichiometry problems. This is screencast 9.3. Okay, all of these problems relate to the burning of butane, where the balanced chemical equation tells us that 2 moles of butane react with 13 moles of oxygen to make 8 moles of carbon dioxide and 10 moles of water. Fine. Mathematically speaking, this means they're equivalent. So we can express either one as a conversion factor. Here's the question. How many moles of carbon dioxide will be produced from 1 mole of butane with plenty of oxygen? Plenty of oxygen means we can ignore it. We don't have to worry about it. To solve these problems, you start with what you're given, which is 1 mole of butane, and you figure out how many moles of carbon dioxide it's equivalent to. Look, I did this in my head. I said, oh, the answer is going to be 4. And that's because we know, hold on, don't show that message again. We know that any time you have 1 mole of carbon dioxide, 2 moles of butane make 8 moles of carbon dioxide. It's a 4-to-1 increase. So I just went ahead and did that in my head. You could also do it as a one-step conversion. Here's one where you have to do it mathematically, and we'll show the one-step conversion. We're given 17.26 moles of butane. We recognize that it's a mole-to-mole, therefore a one-step conversion, so we draw one line. And we go to where we need to go, which is we need to go to how many moles of oxygen it will give us. And I should have written it right there. It's going to show up though. And we know that 2 moles of butane is equivalent to 13 moles of oxygen. It's a 6.5 times increase, and therefore it's 112.2 moles of oxygen. Start with what you're given, figure out how many steps it is, figure out where you're going. Go ahead, write it all down, and then draw on your conversion factors and convert. Make sure you cancel your units. Here's a third one. How many moles of butane react with 0.42 moles of oxygen? We're given 0.42 moles of oxygen. We see it's a mole-to-mole conversion, so it's one step, and we're going to moles of butane. And we know that anytime you have 13 moles of oxygen, it's equivalent to 2 moles of butane. So this will be a 6.5 time decrease, if you will, or about 1/6 of the final answer. And that's 0.065 moles of oxygen. Okay, mole-to-gram conversions are two-steppers. So imagine we have 3 moles of butane. How many grams of carbon dioxide will it produce? Okay, start with what you're given, 3 moles of butane. Recognize that it's a two-stepper, moles to grams. Draw on your 2 steps, and we need to get to grams of carbon dioxide. To do that, we go from moles of butane to moles of carbon dioxide, and now it's a 4-fold increase. And now we're always going to put moles of carbon dioxide down there, and then grams of carbon dioxide, where 1 mole of carbon dioxide weighs 44 grams. We know that from looking at the periodic table. 12 plus 32 makes 44. Multiply it all through, cancel your units, you get 528 grams of carbon dioxide. Here's one that I'd like you to try before you actually look at the answer. Please pause the video, give it a shot, you'll be glad you did. I hope you've tried it, and I hope you got the same answer that I did. Here we go. Start with what you're given, 4 moles of butane. Recognize it's a two-step conversion because we're going from moles to grams. And we'll go from moles of butane to moles of oxygen, 6.5 times increase, 13/2. And then from moles of oxygen to 32 grams of oxygen. Each mole of oxygen has a molar mass of 16 grams per mole. It's diatomic, so 32. And punch it all through. Did you get 832 grams of oxygen? If so, congratulations. This is Screencast 9.3.